Good afternoon. My name is Ivan. So I'm a principal network engineer and manager for Microsoft Azure. So I would like to take this opportunity to talk about what we have done to migrate a bunch of regions from old architecture to new architecture, and some of the challenges that we face, and some of the solutions we put together. So let me put out the problem statements. Right, for the last 5 years, Azure have been going 10x. So we have to actually migrate a lot of old infrastructure to new infrastructures. So question is, how do we actually test on MOP? So here are some of the criteria. I think everyone would kind of agree. So we are 24/7 business, so we don't have any downtime for any customer. So when we do migrations, we also look at the traffic volume as well. The volume is pretty much the same for every single day. So there's no low volume day that we can actually go and choose to do migrations. And the criteria for us is when we do the migrations, we cannot actually impact the customer because they're 24/7. Some of the challenge on our end is this migration need to be repeated for 30 plus regions. So we need to have scale it out for multiple teams to help us to do migrations. So how can we actually guarantee the quality of the migrations? So let's talk about a MOP, method of operations. So traditionally, what we do is we figure out idea how we want to do the migrations. We go into lab, get a few devices, put together, do some testing. So we do like unit testing, so we test on one boxes, make sure the command work, make sure there's no syntax errors. We do some small scale testing by replicate the production network using small number of devices, connect them together, trying to see does the MOP actually make sense? If you execute that sequence of steps, would it actually cause unexpected impact, right? Then we go to production, say, okay, we go to a staging production, we try it. If it doesn't work, we roll back and try again. So when we think about this approach, to us, it's not good enough. It's not acceptable. Because we don't want to test in productions. We don't want to test using customer traffic. So what do we do? So a couple of us actually come together and think about how can we actually solve these problems? So what if we can actually create an emulated replica production network? Then we can actually test out the whole MOP end to end, and even automate the testing as well. What if we can hit a button, hit a command, reset the environment, and try different MOP idea? Meaning I can try different way to actually do certain things and evaluate the impact. And try it again, because it's all automated, right? And with this kind of environment, we can actually go and practice. So we can actually have the engineer go and practice couple hundred times if they want, make sure they know exactly what they're doing, so they build a mental picture of the MOP. We can actually bring in a new team members from other team as well to actually train them on the procedures. So when they go and do the migration, this is not the first time they actually look at the MOP. This is not the first time they look at the devices. This is not the first time they actually look at the toolings. So at the end, we build something we call Open Network Emulator. So we were able to create a replica of a production network. In some instance, we actually have about 5,000 routers in that replications, and we use it for testing. So we'll get into a little bit details. So if you're familiar with GNS3, so this is GNS3 that deploy in a cloud environment that you can scale. So this is what that is. Think about in productions, we have the hardware, we have software, we have configurations. So we take the hardware out, we virtualize it, put it on top of Azure, and run the real network OS that we're using in productions, and push our configuration to it. So that's how we create environments. So here is a detailed pictures. So in our data center, we actually describe our production network using a lot of metadata. So we actually have a blueprint before we actually build a network. So by using that data, it's actually help us to do this, create a replica of our production network. Using that metadata, we create a software to go into Azure. We have our own subscriptions to go and actually bring up a bunch of VMs that with a networking OS on it. Example, today we support Sonic, which is our in-house operation system that we have a talk yesterday. We support other vendors as well, Cisco, Arista, and Junipers. So we stood up the VMs, we create an overlay network to actually connect them together according to how we connect in our production network. We push the configuration that we have from productions to these virtualized devices. And we have jump boxes that we can actually run our toolings, Windows, Linux, different type of jump box, different type of toolings. So everything is set up like this. So imagine this is automated. So all I need to do is go in the portal that we have and list of devices I'm interested in, emulated. We'll fetch the data from our metadata system to actually build all the interconnection between all these devices. And we will have a jump box that you can log in. By going through the jump box, you can actually log into all these networking devices. The user experience from a network engineer point of view is just like normal router. We don't actually see the difference. So that is how the environment being set up. So the next one is the typical workflow that we do for the MOP validations. So think about as a network engineer, I can create a replica on a region that I'm interested in doing migration work or interested in doing a testing the MOP idea or anything else that you want to test. We use our tools to actually apply the configuration to all the devices. Right? For example, your MOP have certain steps, you do certain things, you ship traffic away, ship it back, and all this. So we execute the MOP automatically in the environment. We define a bunch of validation testing to actually see does it actually create impact during every single step. And if you find any problem which is not expected, so we have the output data back to the user. So the user can actually look at it and say, oh, that step doesn't make a lot of sense because we actually cut off the default route to the data center, which is pretty bad, right? So then the user actually can go in and look at the step and see what happened, what's going on. They can actually log into the virtual environment to do live troubleshooting as well. But remember, this is all virtual, so there's no customer impact. So we can actually repeat this a couple of times. We have automation help us to actually go and submit a MOP, to execute a MOP, do the testing, give feedback to the users, right? If it pass, then we'll go to our cab and schedule for production change. So by using these methods, as I mentioned, a couple of things we can do. We can write a MOP, pass it through the system. We can catch all the syntax errors, make sure the command that we put in actually work. Different vendor, different commands, so that actually help a lot. We can use it as a testing environment for ideas. So I may think about different way to ship traffic. I may think about different way to move traffic around, right? I can actually use this for testing to see what is the control plane impact. And how does our tooling actually work as well? Can our toolings scales in a certain way? Do we have any bugs on our toolings? And this also help us to actually do training as well. So if I get a new engineer on board, I can actually set up an environment for him or her. So, and he or she can actually go through the MOP and go and execute. He or she can do it by hand, so he can actually get a sense of how everything working. He or she can actually do the show command to understand more of how the MOP actually being created and the reason behind the MOP as well. So this is extremely powerful because you have a hand-on aspect of running a migrations. One thing we don't want to see is the person actually running a migration the first time actually look at the MOP. That is a disaster. That will easily become a disaster. So using this couple of methods, so we have completed all the major migration for the last 2 years. So we have been working on the migration for the last 2 years. All the major migration already completed. So far, there's no customer impacts. There's no news on the internet that actually have any problems, so it's good news for us. We found a lot of bugs from the initial couple of the MOP and the tooling. So we find configuration problems, typo of the commands. Our management script have some bugs as well. We find some OS problems that causing actually some weird behavior. And so as I mentioned, without this system, we can easily cause about 5 different outages, which is quite a big outages. So that is what I want to talk about. I will open up for questions. Okay, so let me go to one slide I want to call out. So the one network emulator, the detail is actually on the link. The presentation will be available. If you have any questions, you can email the alias, which is the software team, or if you have any questions on how to use it, user experience, you can talk to me. I will be around as well. Questions?
Yes.
Yeah.
Christian Petras, Danik. Is it possible to use this open network emulator for layer 2 stuff as well?
Yes.
Oh, cool.
So basically, we are emulating the, we are connecting a bunch of VM together. The VM is a real OS.
Okay.
Right. So you can actually try that as well if you're interested.
Okay, great, thanks.
Hi, Evan. Blaine Williams, Juniper Networks. I'm just curious, do you guys have any plans to productize this for other folks around the room to try to do this type of thing in Azure for their setups?
Yes, so internally we have a plan to open source this, but unfortunately I don't have the date yet. Thank you.